Now, some of the reasons for difference in the climates, okay? So guys, in this video, we're going to understand the longitude and latitude, okay? I've already explained the longitude and latitude in my previous videos, but just for the record, I'm going to do it over here again as well. So let me just go through another page. Guys, I'm sorry for the picture is a little bit cropped. So please just grab your books because I don't want you to, miss these words which are cropped over here. So now, yeah, speaking about the latitude first. Yeah. So it says over here that in figure 1.24 shows, in 1.24, the previous one, the entire globe that we were seeing. So they're saying that the latitude shows us that the places at or near the equator are much hotter than those near the north and south poles. Yeah, it's very common sense. This shows the temperature are related to the latitudes of places, okay, and shows that the bundle of the sun rays reaching reaching point number A. Okay, check this out. So actually, we're talking about the latitude situation over here. So if you see this situation over here, so it says over here that technically, if you see this picture in this way, okay. So what do you think? For instance, just imagine that over here you have the sun. So for instance, over here we are having the sun. The sun is not square; it's like in a round shape. But just for the record, just understand that this is sun. Okay. So for instance, we are having a sun over here. Okay. You know what? What if I literally draw a sun for you? I have the equipment, so why not to make you understand this in a much nicer way? Yeah. Okay, let me just select the highlighter. So imagine, guys, here you are having the sun. Okay. Here we are having the sun, right? So after, okay, let me just color the sun a little bit. Yeah, let me just make sure that it looks like a sun. Yeah, it does look like a sun. Nice, good. A little bit. So, okay. So if you see this entire Earth, okay, this is the line of equator, okay, over here. So it's saying over here, the places, so actually the thing that I want to say is that the places which are near the sun tend to be more hotter. For instance, point number B, okay, but where if you can see that the distance, so you need to understand the distance between point number B till point number A. So there's a distance, okay, and of course the more sunlight has to travel this distance, it's gonna lose its impact. It's gonna get a little bit low. It can get a little bit low in intensity, whereas because the distance of the B is near to the sun, like if you we take the technical this entire distance from the sun, it seems to be a little bit more nearer to as compared that to A. The A is a little bit far away from sun and B is a little bit nearer to the sun. So that's why the places which are near the equator, line of equator, they tend to be more warmer as compared to the southern hemisphere and as compared to the northern hemisphere. So this is something technical that you guys need to understand over here, right? Okay, moving further, that so it says that there we have 2 points over here. Point number 1 over says over us to here is that reaching A has passed through the greater thickness of the Earth's atmosphere more than B. Of course, I mean, this is true. So the Earth's atmosphere, so this is the atmospheric line of Earth, okay? So here, of course, the more distance, the more atmosphere is being covered to, cross this entire place instead of, this place. This is like a very short distance that the sun rays has to travel to, penetrate in the atmosphere of the Earth. And it says that, and reaching A covers a large area of the Earth's surface than B. See, now the second point actually tells us over here. I'm sorry, guys, I've literally made a mess over here. Let me just remove all these things. Okay, so guys, now you understood the point number 1. The point number 2 over here says that it covers a larger area of the Earth's surface than the B. So over here it says that the sun, okay, let us draw our sun back. So the sun actually over here, what it does that when it's pointing at point number B, so it's actually focusing. It's only focusing on a little point. It's getting opportunity to focus on a little point. But if you see over here that it is not getting an opportunity to focus, but instead of that, it's kind of like spreading all over this area, and it has to cross a huge thick area of the atmosphere instead of this situation where it only has to cross a little bit area of the atmosphere, because atmosphere that plays, we have studied this, that plays a huge role blocking the sun's heat as well, right? Remember the clouds, they reflect back in the atmosphere as well. The clouds absorb as well a lot of the heat from the sun, right? Now speaking about the altitude, guys, so okay, sorry, before we continue, let me just finish the last point. So over here it says that For both of these reasons, places at A will be colder than the places at B. Of course, it's a very common sense thing, very logical thing to understand. Thus, the distance from the places from the equator, and for example, their latitude influences their temperature. Yeah, so latitude. So this is how the latitude plays a role in this entire thing. Okay. Now let's talk about the altitude. Okay. So guys, you need to go and watch the previous videos as well. That what is the difference between the latitude, longitude, and the altitude. I've explained everything. So just for the record, lines of latitude and lines of longitude. So the longitudinal lines are something that are from north to south. They are like this, and if the lines of the latitude are in the horizontal shape. So just for the record, I hope that you understand the difference between longitude and latitude. And now the altitude. Altitude is actually the height that we're talking about over here. So guys, let me show you a picture of latitude, the lines of latitude and the lines of longitude. So on the left side of the screen, you can see the lines of the latitude, which are, from the east to west or west to east. And that's how they are, bifurcating the earth. And then you have the equator line, which is also horizontal. Then on the another side, you can see the lines of, let's say, the longitude, which are from North Pole to south or south to north. And the line which is bifurcating them, that's called the prime meridian. And actually, I've explained the concept of the prime meridian as well in my previous video. So go and watch that to understand. So now let's get to the further topic over here. Now let's try to understand the altitude over here, guys. So it says over here that when the Earth's surface heats the air above it, the water vapor clouds and the dust prevents this heat from escaping rapidly into the space. However, at the top of the high mountains, the air is thin and contains very little dust or water vapor. So any heat escapes rapidly and the air remains cold. If a mountain is 1,000 meters high, okay, if the mountain is 1,000 meters high, which is like around 1 kilometer, right, high, and the temperature at the bottom is 6.5 degrees Celsius, then it will be 0 at the top. So guys, it's explaining in a very simple and very easy concept. It's saying over here, when the Earth's surface heats the air above it, so what actually happens, what actually takes place is that the water vapor clouds and dust prevent this heat from escaping rapidly into the space. Yeah, that's pretty obvious that when the Earth is getting warmer, the dust and the clouds and everything, it's like preventing. So these atmospheric line. Also, so these all of things are like protecting it to escape into the space. Okay, it's like protecting it from to escape in the space. So however, at the top of the high mountain, now we are taking another example of high mountain. So they're telling that at the high mountain the air is thin. The air is like, so say maybe a less denser, it's a little bit very, very thin, and contains a very little dust or water vapor. It contains very little dust or water vapors. Okay, so it means it's thin. Yeah, it's not thick. It doesn't have any other things in it. So any heat escapes rapidly and the air remains cooled. If the mountain is 1,000 meters high, the temperature at the bottom is 6.5 degrees Celsius, and at the top it will be like 0 degrees Celsius. Yeah, it's pretty very kind of situation where we all have been. Not all, but the ones who have traveled to the northern areas. So the more higher you go, the temperature gets a little bit lower. It gets a little bit cooler as well at the same time.